Alright, hi students again. This is video number 3 to go over how to do numbers 12 and 13 on your test review. So you're going to have to graph and analyze this quartic polynomial function. So I need you to first go into y equals and type your function in. You can hit pause if you need to do this, because I need you to practice this with me on a calculator. Pause whenever you need me to slow down, in essence, because I can't slow down on a video, so just hit pause. So first graph it, and the first thing I want you to recognize is that on your paper, your window here is set. It's negative 10 to 10, but evidently it's been adjusted to be able to fit the graph. So when we hit graph, we can actually see that in a standard viewing window from negative 10 to 10, you don't see all the critical points. So note that in the directions it says to be ensured to include all critical points when you graph. So when you graph, I also want you to label those critical points. So let's make note that your critical points include all the zeros of the function, meaning the x-intercepts. You must include the y-intercept, which note is your constant term right here. That's your y-intercept. And it also needs all max and min values. Okay? So make sure that all those are included. So if I look at the graph right now, I don't see as high as I need to. But what I do see is that somewhere between, it looks like about round 1, up here my y value is, it'll reach a peak and then change direction. So I'm going to look at my table by going to second graph, and I see that when x is 1, that in fact it does go up to 12. So that tells me that if I go to my window, I need it to see higher on my y-axis, so I'm going to change my y max, because my y-axis goes up and down, and I'm going to change it to about 15. I always like to leave a little bit of room. So let's see how that helps. Alright, so now we can see, oh great, we can see all of our critical points perfectly. So note that we need to find our zeros, so 1, 2, 3, 4, there are 4 of them, plus we have a relative max here, a relative max here, and a relative min here. So that's 3 more points, making 7, plus our y-intercept here of negative 3. So that's our 8th point. We have to have 8 ordered pairs on this graph. So that's 8 points on your test, is labeling and making sure you've graphed those 8 coordinates. So the first thing I want to do is find my zeros. So to do that, think zeros, 0. I need to put 0 in at y2. I then graph it. Oh, and in fact, you can actually go over here and change it to a bold line so that when you graph it, you can actually see it graph in bold. So here comes your bold line at y equals 0. And what we want the calculator to do now is to find the intersection between this horizontal line and our quartic function. So we're going to hit second trace 5 because we want the intersection. And I'm going to move, we only move our left and right values to move along our function, our left and right arrows. So I'm going to move it to about there, that's good, and hit enter, enter, enter. And this is negative 3.9. I want you to make sure you round to the 10th place. So negative 3.90 is the point I need to put on my graph. So here, note that if this is negative 10, then halfway here is negative 5. So if I want negative 3.9, it's almost to negative 4. So if that was 1, 2.5, 3, close to 4, about there is pretty good. Since you'll estimate, it's a little hard to see on your graph. It's probably a little better on my graph than it is yours, but I promise the one on the test you can see very clearly. So let's make sure we put negative 3.9, 0 to indicate that ordered pair. I am going to be looking for all 8 of the ordered pairs. So the next intersection, let's find it, second trace 5, and let's move our right arrow, enter, 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 and we get negative 2.2. So negative 2.2 is going to be right about here. So I'm going to just come up here and put negative 2.20 for my ordered pair. Moving along, second trace 5. And I'm going to hit my right arrow to arrow over to my next 0 and hit enter, enter, enter. And I get 0.2. Well, 0.2 is barely past 0, so go right past the origin. Put a point there, and let's do 0.20. 0.20. Make sure you put the ordered pair up there. And then repeat the process. Last one. Enter, enter, enter. 1.90. So 1.9 is almost a 2, right about there. And I'm going to put 1.90. So I now have 4 out of my 8 critical points. So that's half credit on graphing by identifying those points. Next, let's go ahead and throw our y-intercept in there. Our y-intercept is at -3. So if this is -10, halfway is -5. So -3 is right about there. And I'm going to put 0, -3 to indicate my ordered pair. Now, we don't use that ordered pair to determine any intervals to answer these questions. However, that is a critical point I'm going to expect to see on your graph. Next, we need to find our relative maxes here and our relative min down here. So to do that, I want it to calculate, so I can hit second, trace, and let's do our maximums first. So we have to mark our left bound and right bound, so I'm going to arrow all the way and just barely go to the left side. I'm going to mark my left on the left and then my right on the right. So I hit enter to mark my left, move it over to the right, mark it by hitting enter again. Now you can see there's actually 2 arrows there to say, okay, we're going to find the max in between there. And now I want it to guess, so I'm going to hit enter. And there it is, -3.2. Make sure it says maximum. You are not done with the process until it says maximum. So -3.2 and 13. So we can actually write our max from that. Remember your y max and mins, that's your y at the x value. So I'm going to go ahead and fill in these blanks while I'm at it. Oh shoot. Second trace, max, sorry. So we do the y value, which is 13, at the x value of -3.2. Okay? Let's find our next one. Second trace, max again. I'm going to use my right arrow here to move my cursor over here. I mark it on the left side, move it over to the right, mark it by hitting enter, and then hit enter one more time. And again, it says maximum, so I know I finished the process. So it looks like they're at the same height here. So 13, oops, sorry, I need to put it up here. 13 at 1.2 for my other one. Sorry about that. Forget, I've got to make sure it's on the screen. 13 at 1.2. All right, next I'm going to go put these 2 ordered pairs on my graph. So that means at -3.2, about in here, and then up to 13. There's 10, about 13 is about there. I'm more concerned with making sure you have the correct ordered pairs than worried about, oh my goodness, where's the point on the graph. It should be reasonable if you can't see the grid really well. And my other one is 1.2, 13. So right about here, up to 13. And I'm going to write the order pair 1.2 and 13. This is especially helpful because you're going to need to write your intervals of increase, decrease, and where they are above the x-axis and where they are below the x-axis using the coordinates, the x-coordinates from these points. So very important. All right, next we simply need to find our min. We've got 1, 2, 3, 4, 5, 6, 7 order pairs. I told you there would be 8 if it's this quartic. That doesn't mean every one will have 8. It means this function has 8 critical points. So let's go about finding our minimum. So second trace, 3, our minimum. And I need to move my cursor down here. Well, that's right about where my min is, but I need to go to the left of it, mark it by hitting enter. Go to the right of it to set the right bound, mark it by hitting enter. Yes, we want it to guess, so hit enter again, and it should say minimum. And we see it is at -1, -12. So we can graph that. -1, -12 would be about here. And that means we can also do our relative min. So remember, it's your y at x, so negative 12 at negative 1. So now that we've got this graph, we want to make sure that we connect all of our points. So do your best to connect them like they look on the graph. Doesn't have to be beautiful, mine isn't, but it makes sense. Okay? Next, we've got to do intervals of increase. So I told you to always underline or circle your x values to help you focus on these x values. Only, I'm not going to do it for my y-intercept. Only the zeros and the max and mins of my function. So that one there is 102.2. And I also said to make sure you put negative infinity and positive infinity at the ends of your graph. Negative infinity on the left, negative infinity on the right. Now we're ready to do intervals of increase. So if I take my finger and start at negative infinity and trace along, I am increasing, then here I'm decreasing, then I am increasing, then I am decreasing. So that's exactly how we want to do our intervals. So I'm going to start, it starts by increasing from negative infinity, so I'm going to say negative infinity to negative 3.2. Then it starts to decrease from negative 3.2 down to negative 1. Then it increases from negative 1 up to 1.2. Then it decreases from 1.2 to infinity. So negative infinity to negative 3.2 increases, decreases from negative 3.2 to negative 1, that's the x from this order pair here, then increases from negative 1 to 1.2, and decreases from 1.2 to positive infinity. Next, we need to do our intervals where x is above, f of x, meaning our function is above the x-axis. So I'm going to ignore the bottom and just look at where it's above. At this point, we use 0. So let me make a little note here, that for these here, you're going to use your max and mins. And for intervals where it is above and below, you're going to use the zeros. Okay? Use your zeros for that. So let's start from left to right, and we want to use these 4 coordinates here. So it is above the x-axis from negative 3.9. Oops. Not a parent here. Negative 3.9 to negative 2.2. And then it's also, then it goes below, and then it comes above again. It's starting at 0.2, and it stays above the x-axis until 1.9. And that's it. So again, negative 3.9 to negative 2.2, 0.2 to 1.9. Now where it is below the x-axis, we have to say, look down here, we're going to use these zeros again, but remember, you're going to start with negative infinity because here it's below. So from negative infinity up to negative 3.9, it's below. So negative infinity to negative 3.9. Then it picks back up at negative 2.2. It's below, 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 below until we hit 0.2. And then it goes above again. And then at 1.9 it starts to go below. So I'm going to use 1.9 to positive infinity. Okay, so it really just kind of takes some practice there. I'm sorry, it's kind of some sunlight on the screen there. I hope that's better. Now in behavior, remember I taught you that you can use the understanding the signs in the coordinate in which the arrows are. So this is in third quadrant where my points are negative, negative. So for my in behavior, I state that as x approaches negative infinity, f of x approaches negative infinity. Here in quadrant 4, the coordinates of all points in this quadrant are positive then negative. So I can state that as x approaches positive infinity, f of x approaches negative infinity. And that's it for number 12. So 13 is going to be easier because we don't have to worry necessarily about any coordinates. You only have to do one problem like this, but this is a lot of points. So this graph alone is 8. Then you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 points for problem 12. If you skip it, then that's minus 22 points already. So make sure you understand all this graphing stuff. In this case, it was 8 coordinate points. Not every graph will have 8, but this one does. For 13, you are asked to find the minimum degree. So remember we talked about even and odd degreed functions, and that for even degreed functions, both ends either go up or both ends go down. If I take my finger at the bottom left and start to trace along this function, I can count and to determine the degree. 1, 2, 3, 4. That's what you should do. 1, 2, 3, 4. So this minimum degree is 4. Think about that. That should make sense. It means it's at least x to the 4th power as my function. Change this around a little bit more so you can, so the light won't mess you up. All right, so that's x to the 4th. The domain for all polynomial functions, just remember, you just ask yourself, does my graph go left and right forever? And yes, it does. This goes down and left, and this goes down and left and down and right forever. So domain is negative infinity to positive infinity. So your lowest x to your highest x. Range is your lowest y to your highest y. So this does go down to negative infinity, but the highest it goes is up to this point. And if we look at the graph carefully, it looks like it's at about 13 or 13 and a half. I'd be rather flexible if it was this fuzzy on the end here. But so our range, our lowest y is negative infinity. Our highest y is about 13. And it does include that point, so we have to have a bracket at the end. Similar to number 12, both ends go down. So this end is in quadrant 3, negative, negative. This one is positive, negative. So this will help us write our end behavior. As x approaches negative infinity, f of x approaches negative infinity. And as x approaches positive infinity, f of x approaches negative infinity. All right, so we've talked about the number and types of zeros before, as in if it's a 4th degree function, it can cross the x-axis 4 times. So it potentially, just like this one did, it crossed 4 times. 1, 2, 3, 4. But that the degree is equal to the total number of zeros. So in this case, if it's minimum degree 4, then I have 4 zeros. But when we look at this graph, we only have 2 real ones. So I have 4 zeros, but 2 of them are real. So if we don't see any others, in this case we don't see any others at all, then that means that the other 2 zeros are complex or imaginary. So remember, we've been solving equations and we get I. That means that those are the zeros, 2 complex and 2 real. And that concludes the video, so good luck on this.